Hello friends, I welcome you in lecture number 25 on logic. In this lecture we will discuss logical equivalence of two formulas using principal conjunctive or principal disjunctive normal form. In earlier lectures we have shown that how we can show that two formulas are logically equivalent using truth table. Here we are going to show that given two formulas are logically equivalent using normal forms, and now we are familiar with two types of normal forms. One is principal disjunctive normal form and another is principal conjunctive normal form. So using these normal forms also we can prove that given two formulas are logically equivalent. So for that we can either obtain principal disjunctive normal form of both the formulas, or we can obtain principal conjunctive normal form of both the formulas, and if formulas are equivalent then two principal disjunctive normal forms obtained will be same, or two principal conjunctive normal forms obtained will be same. So we understand with the help of this example. Here we have to prove that these two statement formulas are equivalent. Here we have P or P and Q, and on this side we have only one variable, that is P. So first we will find out either PDNF or PCNF of this formula, and same we will do for this, and we will see whether they are same or not. If two formulas are equivalent, then their principal disjunctive normal form or principal conjunctive normal forms will be same. So suppose we obtain principal disjunctive normal form of these two formulas and we check whether they are same or not. Now in our question we have to prove that given formulas are equivalent. So it is already given that two formulas are equivalent and we have to prove them. So first I will obtain principal disjunctive normal form, and if we recall, principal disjunctive normal form is nothing but disjunction of mean terms only. PDNF is disjunction or sum of mean terms only. And if we have two variables P and Q, then we have four mean terms that we are familiar now. Suppose I have two variables P and Q, then I will have P and Q, then P and negation Q, then negation P and Q, and negation P and negation Q. So if we consider disjunction of any of these mean terms, then we will have principal disjunctive normal form for two variables. For three variables we will have 8 mean terms, but in our formula we have two variables, so we will find out PDNF as a disjunction of mean terms which are among these four mean terms. Now here we can see we have disjunction of P and Q. So this is already one mean term out of those four mean terms, but here we have only one variable, so we have to write in such a way that we obtain disjunction of mean terms. And if you recall, we know that we can write P as conjunction of P and T. T is always true, so if we find out P and T, then it is logically equivalent to capital P. So using this, first we write this P as P and T, and we will keep this as it is. This is one mean term. Now here Q is missing, and we know that T is always logically equivalent to P or its negation. So using this logical equivalence, here Q is missing, so we can rewrite T as Q or negation Q, and we keep this as it is, and P and Q. Then we use distributive law here. So this we can rewrite as P and Q. Here we have OR in between, and here we write P and negation Q, and this is as it is, OR P and Q. And again we can see that here we have P and Q or P and Q. So I can first write down these two. Here I can write down P and Q. Using associative property we can reorder all these things, and using commutative law also. And now we know that if we have P or P, then that is logically equivalent to capital P. So instead of P we have P and Q. So P and Q or P and Q, that is logically equivalent to P and Q, and this is as it is, or P and negation Q. And here we have used commutative law. First we interchange these two using commutative law, so that we have to write here. Here we have used the fact that if we have P or Q or Q or P, both are logically equivalent, or we can write that using commutative law. And here we have used distributive law. So whatever law we are using, that we have to mention in the bracket. This is using distributive law of logic. Now here we can see P and Q and P and negation Q, these are two mean terms, and they are written using OR term. So this is nothing but disjunction of mean terms only, and therefore it is principal disjunctive normal form of this formula. So we can give this number 1 here. This we can rewrite here also. So what we obtain, P or P and Q is logically equivalent to this, and this we can use later after finding PDNF of second formula, that is P only. So now we try to write down this principal disjunctive normal form for variable P. So for that, first we rewrite P as P and T. Using this, we know that P can be written as P and T. Again here Q is missing, so T can be rewritten as Q or negation Q. Whatever you are using, that you have to write in this way. Then we will use distributive law. So here I have P and Q or P and negation Q. So this is using distributive law. And now we can see we have two mean terms, and they are connected by OR operator. So this is nothing but principal disjunctive normal form of another formula, capital P. And now we can compare 1 and 2. Here we can see we have P and Q, P and negation Q, and same thing here, P and Q, P and negation Q. That means P or P and Q and P has same principal disjunctive normal form. Therefore from this we can say that these two formulas are equivalent. And we can use this fact also. We can write that if we have two formulas, say A and B, and they are logically equivalent, and this formula B is logically equivalent to another formula, say C, then A is always logically equivalent to C. So that also we can use here. Here this is logically equivalent to this one, and this is logically equivalent to P. Therefore these two are logically equivalent. So now we can write that from 1 and 2 we have P or P and Q. P or P and Q is logically equivalent to capital P. So here we have not used truth table, we have obtained the principal disjunctive normal form of both sides and we find them same, and therefore these two formulas are logically equivalent. So this is another way of proving the logical equivalence of given two formulas. I have written another logical equivalence also. Here I have to prove that this is logically equivalent to P or Q. So first we find out principal disjunctive normal form of P or negation P and Q. This is already mean term containing two variables, so I have to work for this. So I first write P as P and T, and I will keep this as it is, negation P and Q. So what I have used here, P is logically equivalent to P and T. Now here Q is missing, so I will write capital T as Q or negation Q, and I will keep this as it is, negation P and Q. So what we are using here, T is always logically equivalent to variable and its negation or its negation. P or negation P is always a tautology that we can write as capital T, and here Q is missing, therefore I am using this logical equivalence by replacing P by Q. Next step is to use distributive law, and this we can write as P and Q or P and negation Q. P and Q or P and negation Q, and we keep this as it is, negation P and Q. Now we can check whether any mean term is repeating or not. Here I have P and Q, here I have P and negation Q, and here I have negation P and Q. So all the mean terms are distinct, so we give this number 1. Then we obtain principal disjunctive normal form of P or Q. So next part is P or Q, and here P and Q are connected by OR operator, but P is not a mean term, Q is also not a mean term, and we are writing principal disjunctive normal form. Therefore we have to write this as a disjunction of mean terms only. So for that, first we write P as P and T, and similarly we write Q as Q and T. Here Q is missing, so we write T as Q or negation Q, or here P is missing, therefore we write T as P or negation P. Then we use distributive law. Here I can use distributive law, and I will have P and Q OR operator, then P and negation Q. This OR operator as it is. Here also distributive law applies, Q and P OR operator, then Q and negation P. And I will check whether any mean term is repeating. You can see here I have P and Q, here I have Q and P, and using commutative law this I can rewrite as P and Q. So let me write one more step. Here I am writing P and negation Q, and here I am writing Q and P as P and Q, that is P and Q, or Q and negation P. Again I can use commutative law. I can change the order of these two. So let me write one more step. Okay, here I can write this as P and Q, or P and Q, or P and negation Q, or, and here also I can use commutative law and I can rewrite this as negation P and Q. So here we have used commutative laws, using commutative laws. And then we know that if we have P or P, that is logically equivalent to capital P. So here instead of P we have P and Q, or P and Q, that is logically equivalent to P and Q, or P and negation Q, or this term negation P and Q. Now I have disjunction of mean terms only, and now I can compare these two. Okay, I can give this number 2. Here I have P and Q, so you can see here also I have P and Q. Then P and negation Q, so same thing here, P and negation Q. Then negation P and Q, that is also here negation P and Q. So we can see from 1 and 2, this is logically equivalent to this, and this one is also logically equivalent to P or Q. Therefore these two are logically equivalent because they are having same principal disjunctive normal form. By 1 and 2 we can write that P or negation P and Q, P or negation P and Q, that is logically equivalent to P or Q. P or negation P and Q is logically equivalent to P or Q. So this is very easy. You can first find out the principal disjunctive normal form of two formulas, and if you find that PDNF is same for both the formulas, then given formulas are logically equivalent. And if you wish, you can find out principal conjunctive normal form of two formulas, and if they are same, then you can say that two formulas are logically equivalent. So in this lecture we have understood that how we can prove that two formulas are logically equivalent using either principal disjunctive normal form or principal conjunctive normal form. So this is all about this session. I hope you like it. Thanks for watching.